In this video, I'll show you how to solve the ALEKS problem called calculating volume by combining the volume of simple shapes. This problem is describing a tank, so this is a three-dimensional shape here, is describing a tank that is mostly full of water. It says there's 2 centimeters of empty space at the top of the water, and it has an empty round bottom flask inside the tank. So this shape here is the shape of a sphere, and it wants us to calculate the volume of water inside this tank. To do that, we're going to need to calculate the volume of water in the rectangle shape, and then from that subtract the empty space of this sphere. The dimensions of this tank are provided in the problem. It says that it is 24 centimeters long, so that is this dimension right here, 24 centimeters long. It is 15 centimeters wide, so that's going to be that dimension, and it is going to be 11 centimeters deep. And that's the dimension, the depth of the whole entire tank. All of it right there is 11 centimeters. Now notice that it's telling us that it wants to leave 2 centimeters of empty space at the top of the tank. So the depth or the height of the water inside the tank is only 9 centimeters. And then we have the flask here. It is giving us in the problem the diameter of the flask, so we're going to be able to use that to calculate the volume of the flask. So what we're going to want to do is calculate the volume of the rectangle shape. I'm just going to write rectangle, and then from that we are going to subtract the volume of the flask. I'm just going to write sphere. Let's start by calculating the volume of the rectangle shape. The volume of anything like that is going to be the length times the width times the height. The length of ours is 24 centimeters, the width is 15 centimeters, and the height of the water, just the water, is 9 centimeters. So this is 24 times 15 times 9, 3,240 cubic centimeters. And from that, we're going to subtract the volume of a sphere, the sphere. The volume of a sphere is given by the equation 4/3 pi r cubed, where r is the radius. The problem tells us that the diameter of this flask is 8.5 centimeters. So the diameter is 8.5. The radius is half of that, 4.25 centimeters. So we can plug that into this equation, 4/3 pi, and the radius cubed, 4.25 centimeters cubed. We'll use the calculator for that as well. 4/3 times pi times 4.25, I forgot my 4.25 cubed is, oh man, I don't know what's going on here. 4.25 cubed, my gosh. There we go. That is 321.6 cubic centimeters. So going back to this, the amount of water, the volume of water is going to be the volume of the rectangle, which we calculated. Subtract from that the volume of the sphere, which we just calculated. So the volume of water is going to be 3,240 cubic centimeters minus 321.6 cubic centimeters. 3,240 minus that answer is 2,918 cubic centimeters. So this is the volume of water in units of cubic centimeters. Let's see what unit ALEKS wants from us. ALEKS wants this answer to be expressed in units of liters. This is going to be a pretty straightforward conversion. I'm going to remind you, really important conversion factor, 1 cubic centimeter is equal to, straight across, equal to 1 milliliter. So calculating this out in units of cubic centimeters, knowing that 1 cubic centimeter is the same thing as 1 milliliter, we can just straight up write this as 2,918 milliliters. That's just a one-to-one unit swap. Doesn't require any math. And so now we have our volume in units of milliliters, and it's going to be really easy for us to convert that into liters. I'm going to write that conversion up here, 2,918 milliliters. We want to multiply this by a conversion factor that has the milliliter unit on the bottom and the liter unit on top. Milli is the prefix for 10 to the minus 3. So that means 1 milli is 10 to the minus 3. 2,918 times 10 to the minus 3 liters, which is 2.918 liters. ALEKS wants this to the 0.01, which is going to be 2.92 liters.